Dottori, tutto a posto? So, welcome back to another video. And today, actually, I will try to do what I said I would have been doing offline, which is kind of trying to bring to completion this porting to Linux. I don't know how far I can bring it. Hopefully, I could be able to I will be able to build the build system, so compile the build system. But of course, there are many libraries that would require a lot more effort, like the async library and so on. But let's see where I can bring it into, let's say, 1 hour and hopefully not much more. So last time we were here, and this was the situation. I think we had some test that was not working, so let's try to see which one was it. The directory test. So directory test. So this test, I know this test very well. This is creating a directory and some files and trying to copy the directory. And why is it not working? Let's try to give it a look. So it's taking this copy directory that has a file, a test file, and another subdirectory into this copy directory. So it's not even starting. Okay, I guess we'll need to be debugging a little bit. So this fallback copy operator that we did, it's not really going as it should. So let's run again. Oh, now of course it's complaining that we are yeah, we should delete the folders to rerun the tests. So again, okay, let's step one by one. So it's creating the initial directory, it's enumerating, creating directory, enumerating, and going. This already looks suspicious because there are just two directories and it should not be enumerating so much stuff. So I suspect this is just a Stack Overflow at some point, or yeah. Okay, yeah, there is also an Erno that doesn't look very good. Okay, we have an infinite. Let's see, what's the name of the entry? Name. Oh, dot folder. Okay. This is telling me that there is something not right in the FileIterator that is enumerating bogus stuff. So before getting the FileSystemTest properly running, I guess we have to run the FileSystemIterator test, which is disabled. And yeah, definitely we need the FileIterator to work properly. It's also fun because I think that the FileIterator should be I don't know why it should not be working. I guess we will discover. I need to bring this definitely up, so maybe you can do something like that. Return 0. And yeah, let's try to see. We have a build error. FileSystemIterator does not name a type. What's going on? Oh, I kind of did some banana copy and paste, actually banana multi-selection. Okay. This is going to be fun. Okay, so there is something not going right. This test is supposed to be printing, I think, just the files into the executable directory, and so there is something wrong here. I think we need to step into this enumeration POSIX specific code and see what's going on. Yeah, this is just using their end and read there, so it's pretty common POSIX type of way of iterating folders. So let's see what's going on. Item. I would honestly see what's in item. It should have a D name. So the D name is SCTest, yes, because we are enumerating things into this folder. So SCTest, so we are checking if this is dot directory. It's clearly not. Oh, so it's even, this is already wrong, I think, because now we got a dot, actually double dot, but we also got the flag of dot 1 and dot 2. Okay, so this code is totally wrong. How could this be possibly working on macOS? I think, yeah, now it's entering here, but this is all wrong because it's entering with entry name dot. Okay, this is completely wrong, but it's, yeah, I see what's going on. I think that the macOS code, this was written on macOS, and on macOS you always get the dot and the double dot directories entries as the very first things you are enumerating with read there. So this code is expecting, is looping until both of them have been reached, and then it just breaks to execute it. But here we have seen that we got the SC test first, and then the double dot that actually got flagged also incorrectly here, because this is assuming that the order is dot and then double dot. So I think this should be easy to solve. Let's do something like this. So we cannot assume that dot and double dot arrive before anything else, and not even that the single dot comes before the double dot. So we need to do something like, we'll do just as strcmp for dot else, yeah, something of this kind. So we can remove bot conditions, and I would do, yeah, I would break in any case. If we have to expect them in any possible condition, then we should just continue when we got them, because we definitely don't want to go into the processing section with something that is a dot or a double dot, because then you will probably start getting the weird things like the one we have seen when running the test earlier. So, and then this still works, because when the directory enumeration finishes, then we close the recursion stack and we are fine. Okay, trying to run. Okay, let's see now. Item. So now we got a single dot. No, this is wrong. This is not compiled. So I don't know why, but this Makefile setting is not recompiling things properly all the time. So that was clearly stale code that was not supposed to be there. So let's see. So single dot, okay, continue. Okay. Still single dot. Oh, of course, this will be true also when you have double dot. Plus we are not setting the flag, so we should do like this. Okay, got dot equals true, got dot 2 equals true, and I would do this one first. Yeah, this one needs to be done first, else something like this. Let's see. So we got the double dot, still getting the double dot. This is not very good. So this is still not working, I guess. Oh, because we need strcmp equals 0. Of course. This is fancy C library. So we got the dot 2. So what is this item name? Why do we still get? It's really, oh, because of course this is still not compiling, because I need to update the file because this inl file is not taken in consideration. Oh, so now first item with dname SCTest is finally breaking through. Oh, excellent. All right, so this is good. Let's see the next. Dname is double dot. We got dot. We continue. Read dir. And what do we have? Single dot. Continue. Read dir. And end of the game. So this is kinda working. So it's printing the only file that it's in the folder. So just for the sake of it, I would like to create like a new folder, and I don't know if I can create a new file like d.txt, and I just want to see, I think one of the tests is doing the recursion. So let's see if this is working. It's working, yes. Actually, bot tests are doing the recursion, so this looks pretty nice. Okay, let's go back to the other test that was not working, which was the run file, which one is file system test? Yeah, this one. So we were actually, let me run it so we see if it's still, if that was the only issue affecting it. No, it was not the only issue, but at least we got the directory copied over. So there is something else that is failing, but we got one step forward. So let's go here in the, actually, no, let me go back. Are we failing on the same test? Probably not. Yeah, we were failing on this one. So this test is doing the following. It's creating directories and files with some directories, it's scoping it. Then it checks that things exist where they should exist. And then it tries to copy again, but it expects it to fail because we are not overwriting. And I think I remember from the last video that something was not implemented in the overwrite. I think the copy file. Yes, there's a fantastic to-do support options overwrite. So, okay. I think we can do just if options overwrite. So if not options overwrite, because I think the problem here is that we are overwriting in any case. We just open and truncate the file. I mean, if there is no overwrite, probably I can just remove the truncate, but we can do better. So if not, options overwrite, and I don't know, file exists, and it's file2. So if the destination file exists and we are not told to overwrite, we'll just return false. Does it sound correct? This is destination file. Yes, it's the one we opened for write. Actually, let's rename it destination file. And file1 is source file. So if options overwrite and it exists destination file. Now let's not do the same bogus things over and over. Let me force it to recompile so I don't debug things that are out of date. Oh, that was all. Beautiful. Okay, we have the file system test. Yeah, very, very good. Very good. I'm extremely happy. This is going a lot better than I was hoping. So what else do we need to reach? Yeah, file system watcher is definitely not something we want to be looking into right now, because that's not easy for sure. Plugin test for sure not. Socket test, maybe we can enable the socket tests. Yeah, let's try. Socket descriptor test. We just try and we see. It's compiling, it's running, and it works. Oh, that's beautiful. So it's before the string test, so we can see socket descriptor test. Excellent. This test is doing quite some stuff with sockets, creating server. It's like synchronous TCP/IP and DNS resolution, but it's kind of cool that it's working. Okay. Next, which one do we want to attack first? I mean, I would like to do the build. Let's try to do the build. Will the build work? Build and build test and SC build. Yeah, let's see. It's not compiling. Why? Hashing. Oh, yes, we need the hashing. We need the hashing because I think the Xcode writer uses the hashing. Yeah, it's using the hashing. I mean, I could be changing this to be something else, but I don't have a ready CRC anywhere or anything like that, because this needs to generate the hashes for files, for file names in the Xcode project. So I guess we need to figure out the hashing stuff. So the hashing class, it's pretty nice because it uses operating system API to let's say do both single, one-time hashing and rolling, updating hashes of MD5, SH1, and SHA 256 without needing any crypto library. So this is just using operating system APIs. I think I researched that something like that exists on Linux as well. I think it was accessed through socket, file socket, just like almost anything on Linux. So we may be wanna looking into that. at least we can try. So let's say elif SC platform Linux, and here we have Linux stuff. Of course, I have no idea on. Yeah, this branch is kept here for the mscripten build, which is kind of not working for now, but I'm keeping it at least such that it compiles. So let's do elif Linux, and we try to implement this. So this, yeah, I need to remove the build test. So remove the build test and add the hashing test, which of course will fail for now. Let's put it on top, and we just run this one. There's no point in running everything else. Of course, this is failing. So let's see, Linux socket, man, I don't know. There is, so this is one of the modes in which you can create a socket, which is this guy. So it's basically exposing the crypto kernel crypto API in userland through a socket, which makes sense because you create a socket, you send the data in, and you get crypto out or hashing out. So it's the socket abstraction works well. Let's see if we can find something else. Linux AF alg documentation. Kernel user space interface. Actually, I already visited this one, so it looks something that I have already researched. Yes, I remember this page. I have read, and that's where I said, okay, this is something that we can do. So, I have seen there was a section somewhere. Yes, this one. General remarks. So, we want to be using definitely message digest, which is the the hashing stuff. We don't need these. Interface is provided via socket type AF-ELG. So we need AF-ELG. So to interact with the kernel crypto API, socket must be created with a user space application. So the user space invokes send and write system call family, and the result is with read and receive. Okay. To initialize the socket interface, the following sequence must be performed by the consumer. Create a socket of type AF-ELG. With the struct socket add ALG parameter specified below. You have to bind it to accept it, the socket descriptor. The accept system call returns a new file descriptor to be used with a particular Cyper instance. When invoking send, write, on read, receive on system calls to send data to the kernel or to obtain data from the kernel, file descriptor return must be accept must be used. So we have to use the one in the accept. Okay. In place Cyber operation. Yeah, you can use the same buffer. Well, I don't care about this one. Message digest API. Message digest API is to be used for the Cyber operation selected when invoking a bind syscall. This is the data structure. Yeah, I would start exactly with this example, so I can just copy this. The type of the algorithm is hash. See below for the set socket op interface explains how the key can be set for a keyed message digest. Well, we don't have the keyed message digest are the crypto ones. We don't need it. This is just a SHA one. using the send system syscall. So this one uses the send and not the write. Okay, we have to use this flag when doing the update, and then we use the receive. We have to provide a buffer that is enough, otherwise it's talking about truncation and so on. Okay, let's try to do this step by step. So create a socket. So we need to store a socket. I would do int like main socket. I don't know. Let's do -1. I mean, we could be using the file descriptor stuff, but yeah, it's probably not good to add this dependency. So let's switch it to be switch, new type. We have type, yeah, SHA1. Yeah, this case. Yeah, for now, well, let me fill all the cases. MD5. Yeah, let's copy the code that this fantastic page was giving us. So this is what we need in the, yeah, maybe we can declare the socket tag alg here and fill it later. Yeah, let's build it. Doesn't build. Oh, it doesn't know about this AF alg and so on. So what should I include? AF alg include. Yeah. Oh, that's a page somewhere. Yeah, this is Linux kernel stuff. Which include should I be doing? Like AF alg example. I just want to know the includes. Streaming hash. Actually, yeah, this is exactly what we are doing. Okay, we need this level of includes. Okay, that's all we needed. Do we need all of them? Actually, well, it doesn't matter that much. I mean, this is an implementation file. So I suspect that we have also the SHA256 and the MD5, I think, or I hope. We'll see. Now we have to create the socket. So I think there's an initted flag. Yeah. Not initted return false. Actually, if initted return false. No. What we do in the set type? No, in the type we do. So if initted, we need to release the stuff. Okay. Main socket. Main socket equals -1. Then we continue. Then we do main socket equals socket AF alg type. I don't know. It's not even telling us what type we should be doing. Maybe that page before. Well, yeah, I mean, we can even find this debugging. So if main socket equals -1, return false. And yeah, let's do it here and let's see. Of course, ernon 94, eno, and what's the one of the error codes for this thing? Return values. Inval epro do not support. Let's see. So 94 is a socket, not socket type not supported. So definitely we can't be passing 0. Okay. So this is just to remember if we see 94. So we have to try something else. I don't think this is specified anywhere. Yeah. Yeah, let's try. Socket stream is the one we use for TCP/IP, dgram for UDP, and then there's the raw. I don't know if this, maybe it's this one, but let's try the stream first, maybe. And definitely it's not the dgram because that's the UDP one. Yeah, we still have 94. Let's try maybe the raw. No, let's try this one. I mean, one of them will be good. Oh, this one is good. So we created the socket. What else should we be doing? Invoking bind with socket descriptor. Well, that's easy. So it's bind on the main socket with the socket edge. Yeah, this one that the guy just gave us. The pattern here is you always have, you know, those structures that have a different signature, so you always have to reinterpret cast. I know this API, you know, decently because it's very similar to the one in the socket descriptor one. If you see this code of here, it's using, you know, bind also here, it's reinterpret cast also here, so it's the same thing. So it's a struct, I think it's socket edge, I think. Well, let's double check. Bind. Yeah, socket edge. And then, you know, you always have socket edge underscore something. So we want to make it like const socket struct socket edge, address of socket edge, socket len. You need size of SA. That's the pattern. So so if res is -1, return false. Let's see. So this one is going good. Next, invoke accept with the socket descriptor. Accept system calls return with a new file descriptor that is to be used to interact with the cyber instance. Okay, so we need another variable int hash socket. I don't know how to call them. Hash instance, I don't know. So we have to accept file descriptor main socket edge. Well, we don't have an address, and so we don't have a length because this is for IP. That's like the, yeah, when I saw new socket communicate set to edge. Yeah, let's make it 0. if it's not working, I guess we'll try to figure out. I always try with zeros first and then figure out the flags if needed. So we have, so we bind, we accept. Oh, we have the socket. I think we have to close the socket as well if they are not -1, and also if this one is not -1, we should, yeah, this is probably better if we wrap this into a function, but for now that's all right. Okay, so I guess we can return true at this point. Update. This is where we should, in the other places we are doing the actual hash computation. Of course, we should be returning false if not initted here in both places. Now, what is this guy saying on the message digest to use the Sane system syscall? Application provides the data should be processed. The Sane system call allows the following flags to be specified. Message more. If this flag is set, Sane system call acts like a message digest update function where the final hash is not yet calculated. That's exactly what we need, because that's exactly the abstraction of the hashing update. So I need to be doing send. The guy was saying, the guy is the documentation. The documentation says to use a hash socket, so the one returned by accept. So we need data.data, data.size in bytes, flags was here to put this MSG more, yeah. Okay, MSG more, we want a more, int res, if res is -1, return false, otherwise return true. Yeah, let's see if we can run this in the hashing test. So we update, maybe let's put a breakpoint here. Well, I can put it here. So this one went through. So it failed the update. Oh, I'm not setting the init to true. Yeah, because I've not been hitting the second breakpoint. So send worked. Okay. How do we retrieve the hash? Receive. With the receive system call, application can read the message digest from the kernel crypto API. Right? I can't really be thinking about something more simple than this interface. I actually like it very much. POSIX in not always, but in many cases it's really good. I think in a hashing result we already have this hash which has a size that is more than enough for the digest of all algorithms. So I'll just do res.hash and size of res.hash result hash flags. We need flags. No, probably no. I don't know. If we need flags, we will discover. If res is -1, of course we return false. Otherwise we return true. I think I need to set also the size here. So I would, this is not returning the sides. Is RSEV returning the number of bytes, right? Return value. Return the number of bytes received or -1 if an error occurred. Okay. So if res is, I think it can return also 0. Early shutdown return value will be 0. Okay, so anything that is minus or equal to 0 is wrong. Otherwise, it's res.sides. It's for sure this is unsigned. Okay, so we need a static cast sides d res. So res, maybe we can make it. Yeah, then it will conflict with that one. So this is read digest sides. And yeah, let's make it const as well. Beautiful. Yeah, I will place myself here. The digest works. We have something. Oh, this works, guys. Excellent. Linux is not disappointing us, so let's continue. Yes, the suite is running, so this is working. Beautiful. What's next? Now I'm really supercharged. You know, it's it's working a lot more than my expectation. Let's do the build. Can we do the build now? Build test, maybe these ones, we put them on top. Does it compile? Yeah, it does compile. So let's do run build test. Yeah, it compiles now. Run it. Oh, does it work? You know, like this. It just works. So we are generating on Linux project for Xcode and Visual Studio and our beautiful Makefile. So now we have this issue that the Makefile we have generated, if now I do like an SC build, actually I would need also to add the bootstrap, but that Makefile for sure will not work because we hand modified this. They are not the same. You know, other than that, we don't have an exclusion mechanism for now for the files. So I think it's a better idea. It's probably a good idea if before continuing, if I try to compile everything so that at least it compiles, and I think we can do it because on mscripten I think we are compiling even with just empty implementation, and we can use them also for Linux because at that point we don't even need to add mechanism to do the filtering and say, hey, these files, we don't want them on this platform and so on, because we either should be generating two Makefiles or adding like conditional support, which, you know, it could be even cool to have, but it would take too much time in my opinion. So it's probably faster at doing the other way around. So let's do it. So let's enable what we can enable, and let's just fdef what doesn't work. So file descriptor test. Yeah, let's do one by one so we are not overwhelmed by errors. File descriptor test. compiles. So I can put this side by side maybe, so I can be faster. File descriptor test. We have not enabled this one, so let's run it. Another test that works. And I think we are really done with the tests that could be working, because all of the other leftover guys here are not easy at all. And they really would require dedicated sessions. So I'm definitely just trying now to conditionally compile them, because I have everything I need for build, so anything else I can just conditionally compile. Error in stop async. Yeah, why I just said we need to do them one by one, and then I'm doing all of them in a single compile. I don't know. Yeah, it's always the same. Use of incomplete type. Sure, because you should not be using, yeah. So I can probably do like that. This mscripten is just an empty implementation. Yeah, because that's how I made it. So this one is working. Next, file system watcher. I mean, we can watch it fail, but I suspect it will be the same. So even in file system watcher, there is an empty implementation for mscripten that we can leverage and say else. Then there is next one, HTTP client server. These are probably working because they rely only on async, which we just added, but we can try. They work, okay? You know, I'm still compiling. I think you should be able at least to see in the video the task compiling. Actually, I should probably switch to this tab so you can see when it's compiling. Plugin, compiling plugin. Also plugin work, but this, you know, plugin should, well, it works. There is not many questions. Oh, because the dynamic, so the implementation code itself for Linux is actually working for macOS, is working on Linux. Okay, is compiling, sorry, at least on Linux. Okay, the tests should be compiling as well. Yeah. Okay, so we have one less problem now to take care of. We don't need to care about conditionally compiling files. I think we have enabled anything that is humanly possible without, yeah, I need the build test. Anything that is humanly possible without really going deep into hard things like this one or the other ones. The async one for sure is not easy. Okay. Next, the next thing I would like to do now is morphing the generated Makefile so that it compiles here. So what are the differences? Yeah, let's make a diff between those two files, and let's see what differences we should be doing. So the list of files should be the same by now. I mean, I can literally copy this list of file now, and they should be okay. Where am I? Okay, so copying this object list here. They are the same. Compile. Yeah, this works. So what else is different now? Yeah, some spaces. Oh, compile commands. So we need to figure out the compile commands. There is this flag. And there are all of the MJ, Michael Jackson flags. Let's try to do the Michael Jackson flags. We need a way to figure out if we are on CLANG or GCC. So let's do a CLANG define equals. I think we can use the shell. So we should detect CLANG. Of course, it's not here, but we can try to have it. This is a local SC copy, so this is on my Mac. It's not the one on Linux where we have CLANG. So let's run CLANG version. Okay, we can grab CLANG. Okay, this should be, so if we grab something that doesn't exist, okay, returns an error code. So we can grab CLANG, I think quiet, and I don't know, echo, yes, something like that. So if I do, oh, this fails. Well, but it should not print yes. Yeah, I would do something like that. So, okay. Well, we should probably be testing this here. So, yeah, well, probably better doing that GCC slash, because I also have GCC installed, so I can test all the flags here. Yeah, but GCC, I think, yeah, this one should be actual GCC. Yes, okay, so let's try to do an SC build dot command. Okay. Well, you know what? I could be doing this in the VM. I'm wondering where it's easier. Let's do it. You know, let's do it in the VM. Okay. Yeah, why not? So CLANG defined, we can do $shell $cxx minus version. Wanna redirect the IO, I think. Can I do this? Yeah. Well, I guess we can only try. So it doesn't complain. How can I print this? Maybe let's try to print it. CLANG define. Oh, I'm not in the correct file. I need to do it here. So CLANG defined. Syntax error. Do I have a shell? Well, let's say make shell command. Oh, so I just need to do shell things. So what's wrong here? What am I doing wrong? Okay, one by one. Okay, this one works. And CLANG defined is okay. If I do minus version, that's where I get the error. So should I do it like this? Okay. Why it says version not found? Maybe I should just say make detect CLANG, and maybe someone will tell me. Well, but this is just checking the name of the executable, so it's not. I don't like. Yeah, this one. That's exactly what I'm doing. Why is it complaining? Why is it complaining? Parenthesis is unexpected. What am I doing wrong? One syntax error. But it's complaining about the open parenthesis. It's CXX. Yeah, CXX is the compiler. Well, I don't know what's going on. How can I fix this? But if I put it in quotes, it's going. Yeah, but it's sending the command verb, as is, which is incorrect. Oh, so it's the echo that is complaining. Oh, because it executes the shell command. Okay, so let's do yeah, the input redirection. We grab CLANG and we echo yes. So this works. Can I say, like, I think I have some if if eq, yeah, dollar CLANG define yes. So if CLANG, we are going to use also the compile commands one, and else, and if, for example, is it working? So if I make it like this, doesn't look like it's, oh, to test it, I would need to place this first. So now if I make it like something else, it should be failing. No. So no matter what, it's going here. It's taking this branch where it would be, you know, it's of course now failing. Oh, of course, I think this is set to known when, well, it's set to something. So I need to test this on, well, let's keep it this way. Then I will be testing it on the macOS side. Now we also need to detect the OS. OS type equals, we can do the uname, shell, uname. So this should be Linux. So this should be, for example, where we have the frameworks. So now if I make the OS type equals to be Linux, or like Darwin, for example, I think it's Darwin, or you name, yeah, Darwin on macOS. So we make the frameworks like this, else, and if we make the framework nothing. So let's try to add back the frameworks here, and let's see if this is working. Okay, let's just to make sure, if I reverse this, if I make it Linux, will it work? Yeah, okay. Yeah, I prefer to have it the Darwin case here because it's the one that really requires some functions, some frameworks to be linked. Okay, now we need to add back the Michael Jackson flag, Michael Jason flag. How do we add back the Michael Jackson flag? I think we can, I don't know, call a function J if CLANG, and we can define MJ CLANG, and no, is then define and def, I don't know, don't remember. Let's search it. Define and Makefile syntax. define function. Maybe it's oh, this is a terrible site. Well, I just need to know this. And def. Okay. And def. Yeah. Oh, it's even syntax a lightning. So I want to do if a CLANG defined yes. Should I do if eq probably? I don't remember exactly the syntax. I wrote something like this once, but don't remember. I was hoping for the IntelliSense to help me here, but yeah, I will have to look the syntax somewhere. Makefile if inside function syntax. Okay. If is Darwin. Okay, this one. Okay. So we need if CLANG defined. Yes, with the space. Oh, this syntax is terrible, honestly. We print the Michael Jackson. Michael Jason. MJ. Let's see. It's still printing this guy. How can I? Yeah, I need to check it if CLANG defined is yes. So can I make it if AQ CLANG define yes? Okay. Maybe we did it. So this compiles. Well, and then there was another one. There was some other flags that we were, yeah, the no std_lib, the no std_lib. So we want to make it like oh, I'm in the wrong file. Yeah, the no std_lib was removed from here. So we want to make it if aq dollar os, not os type, but CLANG defined yes. Let's say EC test compiler flags, so compiler specific flags, no std_lib plus plus, else, and if like this, and we can put it here. Okay. Now, shall we continue the video? How long is it? It's already 1 hour and 10. Yeah, I think it's better stopping it. I can definitely finish this offline. So what I will be doing, and you will see in the commit, I will be making the Makefile generator basically generate this with this OS conditional, this CLANG conditional, and so that this Makefile will work on macOS and Linux. Same Makefile. So I think if I do it now, it will take at least 30 minutes. So because this is, text generation, but it's tedious because you need to, pay attention to the spaces and all these kind of things. So I don't want to really make the video so long. I mean, I could be continuing it in the next video, but I don't think it's so interesting. So I will do it offline. And the other thing that I will do is I will add another SC bootstrap. So I will modify the build sh here, the bootstrap files, so that it will basically the line that we use to compile, which is here. Yeah, it will need to be another one with GCC, G++, I don't know, whatever, without the nosddlib, and this will be done only on Linux. So I will need some if we are on Linux, if we are on macOS, and that will work to generate our Makefile for Linux. So I think this concludes this journey of porting the beginning of the test suite for Linux, for the test suite of Sane C libraries on Linux. And next, so I'm very happy. I think I was able to achieve actually more than I was expecting. Not everything. Once I'm in the hour range, I just stop thinking about doing something that takes more than a few seconds, because then the video would become too long. I think in the next videos we can try to explore how to port like other libraries. I don't know if the async or one of the other ones that we left outside, but we can try. So, well, thanks for being here. Thanks for listening. Thanks for, seeing me with this fancy blue thing. And see you next time, and have a fun and have a good time with Sane C libraries.